morning. Today we are going to be reviewing dilation, and then later on we're going to have a project that we're going to be starting for the rest of this week. While we're going through this Quizizz, I would like you to pause this video and discuss with a partner what you think the answers are, and you can unpause and we will discuss the answers together. Here we go. My first question says, what does congruent mean? Go ahead and pause this video and discuss with a partner. Okay, we have 3 different choices. I am going to read through them all. So my first choice is 2 congruent figures are the same shape but different sizes. It says 2 geometric figures are the same size. And then 2 geometric figures with the same size and shape. Well, I know that congruent includes the same size and shape, so I need to look for an answer that has both size and shape. If I look at the first one, it says the same shape but different sizes, so that's not the same. They're both not the same. The second option just talks about size. It doesn't even talk about shape. My third option says 2 geometric figures with the same size and shape. And I know congruent means that they're the same in both size and shape, so it has to be this one. Second question says, what is similarity? Again, pause this video, discuss what you think similarity is, and we'll come back and talk about it. Now that you've had time to talk, we're going to go through again our 3 choices. First option is 2 shapes are similar when they are the exact same copy. Second option says 2 shapes are similar when one can become the other shape after a resize, a flip, a slide, or turn. And our third option says 2 shapes are similar when one can become the other shape with no resizing. So there's a lot of words going on here. If I look at the first one, it says 2 shapes are similar when they are the exact same copy. Well, if I know that they're the exact same copy, we know that congruent, our last question, had the same shape and size. So that would be the same copy. So I know that my first option cannot be similarity. If I look at my second option, 2 shapes are similar when one can become the other shape after a resize. Well, I know when I think about resizing, it has to do with dilation, which is something we've been talking about. And I know that we've learned if we flip something over the x-axis or the y-axis or over another point, that those objects are similar if we flip it back over, or if we reslide it, or maybe turn it a certain way, that they could still be similar. So I'm thinking maybe this one is the right answer. If I look at the third one, it says 2 shapes are similar when one can become the other shape with no resizing. Well, I know that a lot of times with similarity, my shape is being dilated, so it's having a new size. So therefore, this second option has to be the correct answer, because they're similar, because right now we've been working a lot with resizing, not necessarily flip, slides, and turns, but just resizing and dilating our polygons or objects that we have. Okay, what is dilation? We kind of just touched on this. Go ahead and pause the video and talk about it, and we'll come back together. hopefully that was a short discussion since we kind of just talked about it and we've been learning about it for a little while now. We have 3 choices again. So changing the object size, changing an object shape, changing the object shape and size. Well, I know that if I'm changing the object size, I can make it bigger or smaller. We've talked about shrinks and stretching. I know if I change the object shape, now I have a completely different object. So that wouldn't make sense because now I'm dealing with a different object. And then changing the object shape and size. Well, again, the last one includes shape again, and we're not wanting to change the shape, so it has to be our first one, changing the object size. Okay, this parallelogram has a dilation factor of what? Before you answer this one, I'm pointing out that the original parallelogram we are starting with, which we should be able to tell just based off our points how they're labeled, is the yellow one. The teal has been dilated, or the yellow one has been dilated and now is the teal one. So our coordinates for our original parallelogram are in black. The coordinates for our new parallelogram are in red. Go ahead and pause this video, discuss, look at the points, see what the factor is that they're being dilated by. Now that you've had time to discuss the dilation factor, since we know our original parallelogram is this yellow one, I'm just checking these points with my teal parallelogram, and I see that I go from -2, 4 to -1, 2. Well, I see that half of -2 is -1 and half of 4 is 2. If I keep checking all my points, 4, 4 changes to 2, 2. Well, half of 4 is 2. If I look at 2, -2, it goes 1, -1. Well, half of 2 is 1. And then I look at my last point D, and it goes from -4, -2 to -2, -1. Well, half of 4 is 2, and half of -4 is -2, and half of -2 would be -1. So now if I'm looking, I see that I took half of each of these numbers, each of these coordinates, and I got that when I take half of it, I got my new parallelogram. So I know that I have a dilation factor of 1/2. I see that my parallelogram shrunk. It got smaller. This triangle has a dilation factor of what? This time, my original triangle is my teal one, and the yellow one is my new triangle. So my teal one is being dilated, either a shrink or a stretch maybe, into this yellow triangle. Go ahead and pause and discuss. Now that we've discussed it, I'm again going to do the same thing. So I'm going to look at my original triangle. I know it's ABC. I see my points here. I'm given my coordinates. And then I look over here, my yellow triangle, and I see new coordinates. Well, I see 0, 2 for point A, and my new point is now 0, 4. My choices are 2, 4, and -2. Well, I know when I'm dilating something, I'm multiplying by some number. Right now we don't know that amount, so we're trying to find that amount. Well, if I multiply by a negative number and I have a positive number, I should have gotten a negative number somewhere over here for my new coordinates, and I didn't get a negative number. So I know that -2 automatically is not even an option. And then I look, and I can rule out 4 pretty easily too, because 0 times 4 is still going to leave me with 0, but 2 times 4 is going to leave me with 8. And over here I have 4. I could do the same thing with my y-coordinate for b, for negative 1. If I multiply negative 1 by 4, I'm going to get negative 4. And I got negative 2, which doesn't make sense. So I automatically am going to go, it has to be 2. But I just want to check. 0 times 2 is 2. 2 times 2 is 4. My new coordinates are 0, 4. That checks. 2 times 2 is 4. So my new point would be 4, negative 1 times 2 is negative 2. So 4, negative 2. Yep, that checks. And then my points are negative 2, negative 2. Well, if I multiply 2 by negative 2, I'm going to get 2 negative 4s. So negative 4, negative 4. So I see that 2 truly is my dilation factor for the teal triangle. Nice job. Now we have answered all our questions. I hope this helped give a little bit of a refresher as to what dilation was and how we can check what it's dilated by. We are going to be working on a project, and I am going to discuss that here in just a second.